Hello, friends. This is Science Talk. I am your host, Jim Massa. I want to discuss with you heavy rains. So let me just give you the long-term forecast. Rain will become more torrential, flash floods more frequent. Very heavy rain is a simple response to increasing global temperatures. Now, I have discussed with you folks before on numerous occasions how dry areas will become drier, wet areas become wetter due to climate change. Well, Canadian scientists have examined an exhaustive collection of rain records for the past 50 years to confirm what climate scientists have been warning us, that episodes of very heavy rain are on the increase. They measured this increase in parts of Canada, most of Europe, the U.S. Midwest and Northeast, Northern Australia, Western Russia, parts of China. Between 2004 and 2013, worldwide, events or episodes of extreme rainfall rain increased by 7%. In Europe and Asia, in the same time period, the rate was an increase of 8.6% in cascades of heavy rain. The scientists report in the journal Water Resources Research that they excluded areas where the records were less than complete, but analyzed 8,700 daily rain records from 100,000 stations that monitor rainfall worldwide. They found that from 1964 to 2013, the frequency of catastrophic downpours increased with each decade. Dr. Simon Papalehiu of the University of Saskatchewan's College of Engineering stated that by introducing a new approach to analyzing extremes using thousands of rain records, we reveal a clear increase in the frequency of extreme rain events over the recent 50 years when global warming accelerated. He continues, this upward trend is highly unlikely to be explained by natural climate variability. Let me repeat that. This upward trend is highly unlikely to be explained by natural climate variability. The probability of this happening to natural climate variability is less than 0.003 under the model assumptions used. So again, climate scientists, we take into account natural variability. We take this into account. We factor this in. When we do the statistical analysis, we then say, okay, this parameter, this factor, this variable, whatever you want to call it, accounts for this percentage seen in the observed responses. This other factor, this amount, and so forth. So basically what they're saying is the observed response here, what's the observed response? Increased rainfall. The observed response, natural climate variability explains basically 0.3% of that response. In other words, diddly squat. As temperatures rise, evaporation increases. Warmer atmosphere can absorb more moisture. I've shared with you guys before that every 1 degree Celsius increase in temperature, the atmosphere can hold 7% more moisture. We've gone about 1.3, almost 1.4, 1.5. So we're looking at what, 8, 9% more moisture in the atmosphere. Well, moisture in the atmosphere is going to eventually come down. So, and we already know that, there's been a significant measured warming, very fast rate when compared to Earth's history. Hydrologists, engineers, planners, climate scientists have been warning for many, many years that human settlements and low-lying terrains are at risk, especially at risk from heavy rainfall. What's the risk from? Flash floods. These flash floods can wreak a number of problems. They can overwhelm sewage treatment plants, which would then, now you have raw sewage all over the place. You then have water contamination. Rain-induced floods have claimed more than 1 million lives since 1980. That's 40 years. And these floods, just to continue with some of the things they can do, and studies have confirmed this, they can trigger landslides, wash away crops, overwhelm buildings, bridges. Like how many times you hear about a bridge being washed out? Flood homes, block road transport. And they expect to be increased because now when you start having huge growths of cities, you've got what? You've got asphalt, you've got concrete, you've got bricks, you've got, right? These things do not absorb water. So the water is going to really rip through. Whereas if you have marshes, forest, grassland, they can slow the water down, especially marshes, and they can, absorb the water. Marshes is something that's called a filtration system. They would be able to absorb more of these increased rainfall. Don't forget, as cities expand, they're using up land. Oftentimes, they start going into marshland, and you have to start, bringing in fill, and then you wash all that stuff out, and buildings start collapsing, so on. Scientists have measured alarming increases in rainfall in urban Australia. They have linked the catastrophic floods delivered by Hurricane Harvey in 2017 over Houston in Texas to global warming, and warn more and worse is on the way. Now, of course, in Australia, with the horrible fires of recent, I'm sure they're wanting some rainfall there. If global warming progresses as climate model projections predict, we have better plan for dealing with frequent heavy rain right now. Our study of records from around the globe shows that potentially devastating bouts of extreme rain are increasing decade by decade, Dr. Papaleo stated. He concludes, we know that rainfall-induced floods can devastate communities and that there are implications of increasing bouts of heavy rain for public health, agriculture, farmers' livelihoods, fishing industry, and insurance, to name just a few. And I listed at the top of this, or listed earlier in the video, some of the things that can happen from heavy rains. So here's yet another ramification of human activity affecting the climate. Thank you for your time. Hello folks, this is Jim here with Science Talk, asking you to please subscribe to my channel and to inform others of my channel and of the work that I do. Please share to social media platforms that you use. Also, as a reminder, don't forget to click the bell so that you know when I load up more videos. Finally, I ask that you support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.